Let's study how we can print and manipulate integer numbers using the printf statement. Let's start with an example. Suppose I wanted to print out to the screen if I have 3 bills worth $5 each, and I have, what do I have, $15. And I can totally do that. If I run this, and I'll do that in a second, it'll print to the screen. If I have 3 bills worth $5 each, then I have $15. Printf is called a function that takes a parameter inside parentheses. So printf is the name of the function, and we have an opening parentheses here and a closing parentheses right there. And in between those comes a parameter. This particular parameter here is called a string of characters. Why is it called a string of characters? Well, because it's literally one character after the next that I put in there. First an I, then an F, then a space, another I, and so forth, until I get to this 3, which is also simply interpreted as a character that's going to be printed to the screen. So let's compile this and run the code, and indeed it prints out if I have 3 bills worth $5 each, then I have $15. Let's go back to edit mode. The printf function is actually way more powerful. It allows us to print out and format numbers in a number of different ways. So let me show you how. We can replace each number with a %d, and I'll explain why we are doing that. D here stands for an integer number. So if we wanted to print other types of numbers, like ones that have decimal places, we would use something else. This %d is called a format specifier. It specifies that wherever I put a %d inside my string of characters, I wish a number to appear. But how do I tell C what number I want printed in place of the %d format specifier? Those numbers get passed in as additional parameters to the printf function. To do so, all you have to do is put a comma right after the string of characters is over, and then you place the numbers that you would like to replace the %d's with. So the first %d here, I wanted that to say 3. So I put that 3 after the comma right here. The next %d, I wanted that to say 5 because I want 3 $5 bills. So I put a comma after the 3, then a 5 and another comma, and now comes the next %d. So that makes $15. So I want this last %d to be replaced with a 15. And so the way this is understood, I'm giving the printf function 4 parameters, namely the first one is the whole string, the second one is that 3, the third one is the 5, and the fourth one is this 15. And what happens when I compile and run this program is that the first %d gets replaced with a first number that comes right after the string. The second %d gets replaced with a second number that comes right after the string, and the third %d gets replaced with a third number that comes after the string. So let's compile and run this code. And indeed it says again, if I have 3 bills worth $5 each, then I have $15. But you can do even more. Let's go back to edit. We can in fact have C do the computation for us. Here I just put 15 because I know 3 times 5 equals 15. But the function is powerful enough for me to be able to put 3 times 5 right there in place of the 15. The times is simply the star character. 3 star 5 stands for 3 times 5. And what's going to happen? The 3 times 5 will be evaluated as 15 and then placed in place of this %d right here. Let's check it out. Compile and run. And indeed it says again, if I have 3 bills worth $5 each, then I have $15. So this is how you can manipulate and print and start to do simple calculations with integer numbers.
I'm going to show you how to do simple calculation using integers with addition, subtraction, multiplication, and parentheses. We won't see the division for now because it's a special case in C and it has a special behavior. We'll see that after. So let's start with a simple calculation with a printf. 3 plus 2 equals, and then I will output the result with %d, and 3 minus 2 equals %d, and 3 times 2 equals %d, and then \n. And then after the quote, I have to do my calculation. So the first %d is to output the calculation that is 3 plus 2. And then with a comma, I do the second parameter, that is 3 minus 2. And then with a comma, the third parameter is 3 multiplied by 2. And then semicolon at the end. Let's compile and run the program. 3 plus 2 equals 5, and 3 minus 2 equals 1, and 3 times 2 equals 6. Great. Let's try another example here with 3 plus 2 times 3 equals %d, and then I will use the parenthesis. So if I open a parenthesis within the quotes, then the closing parenthesis is not written automatically by the editor because we are within the quotes, and this is a special behavior of the editor. So 3 plus 2 with plus 2 within parentheses times 3 equals %d, and then \n to have a new line. And then I have to do a comma with the parentheses. So the first one is 3 plus 2 times 3, and then a comma with another parameter, parentheses. As you can see here, when I typed the opening parenthesis, then the closing one is automatically written by the editor because we are outside of the quotes, so be aware of that. So within the parentheses, we have 3 plus 2, and we do times 3, right? Okay, let's try that. Compile and run. All right, so 3 plus 2 times 3 equals 9, and 3 plus 2 times 3 equals 15 with the parenthesis. All right, so let me put some other example for you that I will copy paste and that you can test by yourself. So here we have different options with different types of calculation, with different types of parentheses, as you can see here. I compile and run and look at the examples output in the terminal. So we have 2 times 8 minus 2 times 7 minus 4 equals -2. And then we have different outputs depending where we put the parentheses. So you can try by yourself and try to put different parentheses or different calculation and try to have your output. Don't forget that if you have multiple %d in the printf, for example, here we have 3 of them, then you have to have 3 parameters. It means 3 comma, first one to separate with the quotes, second one to separate the first parameter with the second, and the third to separate the second with the third. Right, do your own calculation right now with this codecast. Try it.
We will now learn how to memorize an integer value and reuse it later on in a program. To do so, we use what's called variables. One can think of variables as little memory boxes. These memory boxes contain the things we'd like to remember and are stored in the computer's memory. Right now, what we'd like to memorize is an integer value. Let's look at this simple program here. What it does is it has 3 printf statements and it prints out 3 strings of characters and it has some %d, some format specifiers in them that are replaced by the numbers that we place as additional parameters into the printf statement. So for example, this first printf statement will print I am, and then it will replace the %d with a 17, so it'll print I am 17 years old. On the next line, it'll print in 8 years, I will be 17 plus 8, which equals 25 years old. And then in the third line, it'll print 11 years ago. I was 17 minus 11, which is 6 years old. So let's compile and run this just to make sure everything's good. And indeed, I'm 17 years old. In 8 years, I'll be 25 years old. And 11 years ago, I was 6 years old. Let's go back to edit mode. And suppose I wanted to memorize this 17 right here. To do so, I need to first create a variable, so a memory box with room to store the 17 in. And then I need to place that 17 into this memory box. So let's write down 2 comments of the things I need to do. I need to create a variable to store an integer value. And next, I need to assign a value to that variable. And how do I do these 2 things? In C, an integer is called an int, just int. The abbreviation int is used for integer. So to create a variable that can hold integer values, I type int to tell C that's what I want to store, then it's space, and then I need to assign a name to my memory box. And since I want to store my age in there, why don't I call this name age? This line, int age semicolon, creates a memory box to which I can later on refer by the name of age. Next, I need to place a value into age, namely my 17. To do so, I type the name of the variable on the left, then an equal sign, and this equal sign means in C that I want to put a value into age. I want to initialize the variable age with a number, and that number goes on the right-hand side, followed by a semicolon. So this is not a mathematical equal sign that compares whether the 2 sides are equal. It's called an assignment statement. We're assigning the value 17 to the variable age, meaning we're placing that 17 into this memory box so that we can remember it later. So now how do I use the fact that I stored the 17 in the variable age? I can simply go ahead and replace the 17 everywhere in my program with this variable age. And what happens when the program runs is it sees, okay, a variable shows up. That means I need to go ahead and find the value that's stored in that variable and put it right here. So when the program runs, it'll replace age with 17, and then it'll put the 17 in place of the %d, and it'll still print I am 17 years old. I do the same thing for this 17. I put age instead of 17, and also here I put age instead of 17. Let's run this program and make sure it actually works. So we compile and then hit the run button, and it says indeed I am 17 years old. So indeed up here this %d was replaced with a value that's stored in age. In %d years, that's 8 years. In 8 years I will be %d years old. That's age plus 8. Age has the value 17. 17 plus 8 equals 25. And finally, 11 years ago, I was age minus 11. Age has the value 17. 17 minus 11 equals 6. So I was 6 years old. So it worked just like we envisioned. Let's go back to edit mode. So why is this so useful? Well, I can now actually change the age quite easily. Suppose I'm no longer 17 years old, but I'm rather 29 years old. So I changed the assignment value here, age equals 29 instead of age equals 17. And that's all I have to do. I don't have to go change the 17 that used to sit here and make that a 29, and the one that used to sit here, make that a 29, and the one that used to sit here and make it a 29. I simply change age in one place of my program. And when I now compile and run the program, it has replaced age with 29 everywhere. So in 8 years, I will be 37 years old. 11 years ago, I was 18 years old. Let's do this one more time just for fun. So we go back to edit, and let's say I am 47 years old. I can compile and run this code, and all of a sudden age has the value 47 wherever I use it in my program. So this makes using and reusing a value really easy because you can change that value in one place rather than have to find every place in your program where you actually use the specific value. So this is how to create and initialize variables and how to use them in your program in the case of integers.
How do you vary the value of a variable? That's what I'm going to show you in this codecast. I'm going to do an example of a bank account with a balance, and we will vary the value of this balance. So first I'm going to create, that is, declare a variable that can contain integer values, and the name is balance. So here, creating a variable containing integer values. And I'm going to assign the value 50, meaning that first I put $50 in my bank account. So assigning the value 50 into the balance variable. And then I'm going to print I have $dollars in my account, new line, and I want to show the value of the variable balance. Let's compile and run the program. I have $50 in my account. That's the output of the program in the terminal. Good. Now I'm going to show you how we can vary the value of this variable. Let's try to do an expense of $40. Oops, $40. So I mean that I want to reassign another time the same variable, balance, but with a new value. So I could do something like this. Balance equals balance, I assign the new value 10, which means I had 50, I do an expense of 40, then I have 10. Of course, if I do a printf, I have $dollars in my account, and then I print the value of balance. If I compile and run, in the terminal I have $50 and then I have $10. But that's not what I really want to do. Instead, I want the computation to occur. So I could say 50 minus 10, which is correct because 50 was the old value of balance, minus 40, and that makes 10, of course. The thing here is I want to use the same variable. So it might look strange, but look what I will do here. I will replace 50 with balance. And that, if you look at this line, the first time you see this, it might look a little bit strange because from a mathematical point of view, it's not equality. Balance is not equal to balance minus 40 because this sign here is not equality. This is assignment, and this is quite different, meaning that we first have to retrieve the value balance. So it would be 50. Then we have to do the calculation, minus 40, that makes 10, and the result of the calculation 10, then we assign it to the variable balance. And that's exactly what happens when I compile and run the program. You see, I have $10 in my account after the calculation. Let's continue to make sure you understand what's happening here. I will add $20 in my account. For this, I do the same, balance, and I assigned what? The old value of balance plus 20. And then I will printf, I have $D in my account. Let's compile and run. As you can see here, now I have $30 in my account because it calculated the old value of balance, that was 10, plus 20, and the result, 10 plus 20 equals 30. The result, we assigned it to the same variable balance, and then we print it. Let's continue with an expense of $30, for example. So that would make the instruction balance equals, meaning I assign a new value, and the new value is the old value of balance minus 30. And then let me copy paste this printf just here, and let's compile and run this program. Now I have $0 in my account. $0 with an S. We'll see later on how to test a certain variable and printf a different sentence. Here we would like to printf $0 without an S, of course, but we will see that in the next sections. So here I will just do it manually, and I will get rid of the dollar with a S in the sentence here. So that's how you create a variable and you put a first value in it. And that's how you use it again, meaning that you retrieve the old value, you do a calculation, and the result of the calculation you assign into the same variable. So you can try by yourself by putting different numbers here, and you can even try to multiply by 2 the balance, or try to use multiple times the balance, the old value of the balance, and try to understand what's happening here when you compile and run the program. It's your turn now.